Section 12.7b is about subtracting rational expressions with unlike denominators. In this case, I'd like to factor this denominator on the left side by taking a 3 out. And that's going to give me an a minus 2, and that's going to help me determine my common denominator that I want to get. So now I want to look for the least common denominator like I've been doing. Take every factor, the maximum number of times that it appears. 3 is a factor, I want to take it. I also want to take a minus 2, and I also want to take a plus 2. So that's my common denominator, and in this first fraction I'm missing the a plus 2, so I'm going to multiply by a plus 2 over a plus 2. The second fraction I'm missing the 3 and the a minus 2, so I'll multiply by 3 times the a minus 2. Now we'll distribute the 4 here, make it a 4a plus 8. So that's going to be over 3 times a plus 2, a minus 2. And then we're going to say minus 3a, a minus 2 on top, over 3 times a plus 2, a minus 2. Now you don't have to write this step. If you can do that stuff in your head, fine. I'm just trying to show everyone where these values are coming from. Now we have this negative with the 3a, and when I distribute, I need to distribute the negative and the 3a. So continuing to simplify, we're going to get minus 3a squared, and the negative and negative is a plus. 3 times 2 is 6. And that's going to be over, I'm going to put it together now, over the common denominator of a plus 2, a minus 2 times 3. Continuing now, I'm going to write this top in descending order if I can. So I'll put the a squared first. I see a 4a plus a 6a to be plus a 10a. And then this minus 8 will go on the end. And then the denominator on the bottom. So we will just leave that as my final simplified answer. Here we're asked to find the difference of these two, which means we need to find a least common denominator. On the left denominator there's a 2 and a 3, and on the right there's a 2 and a 2. I want to take the maximum number of 2's, and since there's 2 on the right and 1 on the left, I take 2 of them. But I also want to take the 3 factor, and then I want to take 2 w's for my common denominator. So that's going to be a 12w squared for my common denominator. Well, the left side is missing just a 2, because 2 times 6w squared will give me the 12w squared that I'm looking for. And the left side, or excuse me, the right side needs a 3w to create a 12w squared. And now we'll simplify. 6z minus 3wz all over the common denominator of 12w squared. On the top I can factor out a 3. So 2z minus wz, and that's over 12w squared. Now by factoring the 3 out, I make it into a factor. And now I can cancel that 3 with the 12, leaving a 4 behind. So we end up with 2z minus wz over 4w squared. I can't cancel the 4 and the 2 because the 2 is part of a binomial, and so this is my simplified solution. In this example, we have binomials on the bottom, and I'm going to start by factoring this b squared minus 16 into b plus 4, b minus 4, because it's a difference of squares. And now I'm going to look for the least common denominator. Remember, every factor, the maximum number of times that it appears. There's one b minus 4 on both sides, and there's also a b plus 4 on one of the sides. So that is my common denominator. I'm missing the b plus 4 on the right side, so I'm going to include it. The left side's all good. So I'm going to do some combining here, and you don't have to write this step if you don't need to, but I'm going to do it so everyone sees where I get the next step from. So now that you see that these denominators are common, I'm going to put the next step over the common denominator of b plus 4, b minus 4, and then I'm going to simplify. Distributing the negative 1 gives me a minus b and a minus 4. Like terms on the top, b minus b is nothing, And 8 minus 4 is 4. So 4 over the common denominator of b plus 4, b minus 4. That's actually an okay answer. If you want, you can combine the bottom into b squared minus 16, and I'll accept either one of those. Last example, again I'm going to factor the denominator because it's easier to find the least common denominator. Two factors of negative 10 that add to be 3, positive 5, and negative 2. So now I will look and see the least common denominator is x minus 2 and x plus 5, taking every factor the maximum number of times that it appears, but not a combination. That's why we don't take 2 of the x minus 2's. The right side's good to go, but the left side is missing. Whoops, let me make that green. The left side is missing x plus 5. Now I'm going to distribute this x squared plus 5x, and then I'm going to say minus 3, and I'm going to put it all right together over the one common denominator, x plus 5, x minus 2. So I'm skipping that intermediate step. Some of you can do that, others of you can't. You don't have to skip it if you don't want to. On the top, I do want to factor this and see if there's two factors of 3 that add to be 5. There actually are not. So I'm done.